Hello, everyone. So my name is Orlando Castillo. I'm lead engineer at Chronicled. And today, I'll be talking to you a little bit about zero-knowledge proofs. Cool, zero-knowledge protocols. Specifically, how we leverage this kind of tech to solve some pretty interesting problems in our applications. So as a company, we mainly engineer supply chain operations for our clients. And most of the existing public perception around blockchain's potential utility in this space tends to emphasize how it can promote transparency and visibility amongst the participants in the network, how it will reduce complexity and enforce collaboration. In talking with a lot of supply chain clients ourselves, we find they're really interested in a technological solution to streamline traceability of the items as they move through the networks. But they're also primarily interested in data privacy, which seems to fly against almost the blockchain philosophy. As most of you will probably know, in a blockchain network, all of the participants share an equal view of the data. So the data is public. So how can we go about engineering a solution to solve both of these concerns? Well, let's take a look at a real-world example, and we can come up maybe with a concrete solution. So as a company, a majority of the companies that we collaborate with are pharmaceutical companies. And so companies like Pfizer, McKesson, Genentech. And based on our talks with them, we've come up with a pretty good understanding of how this ecosystem works. Right? So in the pharmaceutical supply chain, the main item that's being transferred is a drug. The various participants can perform a variety of different actions, but conceptually, for our model here, we can really boil it down to three main roles. There's a manufacturer who registers a drug, a distributor who transfers a drug amongst the other participants, and the dispenser who finally consumes the drug by just giving it to some medical clinic, some hospital, some patient, something like that. In 2013, this piece of legislation known as the DSCSA was approved, which basically wants to enforce traceability of the drug as it moves through and among the participants of this network. And it was suggested to do so by essentially serializing each drug item. So each drug is assigned a unique serial number, and that's how you track its movement. OK, so given these constraints of the system, what kind of solutions can we come up with to streamline this process? OK, first initial solution might be we can store a central data source, a transaction log, basically, of all of the events. And when the participants want to register a drug or transfer a drug, they just submit a transaction that adds that event to the log. OK. This really isn't acceptable because who's going to host that data source, right? It doesn't make sense. Each of the individual participants will want to host it individually. Let's go for a more decentralized approach. OK, that's really where blockchain has its power, right? So each of the clients can now participate in the blockchain network, and they share the distributed ledger of all of the events, enforcing traceability of the items. Again, there's another shortcoming here, and it's a shortcoming I highlighted earlier, which is data privacy. These companies really don't want the other companies knowing the specifics of the drugs that they're transferring through this network, right? So we seem to have almost these two diametrically opposed concerns here, right? Each of the participants wants a secure chain of custody of the items as it moves through the network, but individually, they really want to minimize the amount of data that they share to do so. Okay? And so how can we engineer a solution that simultaneously reconciles both of them? The key ingredient here is zero-knowledge protocols. And so the solution that we formalized in the MetaLedger project essentially sets up a permissioned blockchain where each of the participants will cooperate, essentially. And we add on top of this blockchain network smart contracts, which formalize the business rules of the ecosystem. So in the case of the pharmaceutical supply chain, it might be that only a manufacturer can register a drug, and then only a participant registered as a distributor can transfer it. However, we don't actually store the plain events in the blockchain. Instead, we store a piece of the zero-knowledge protocol known as a witness string, which basically doesn't leak any business intelligence information. So then, when one of the participants wants to log an event, let's say a manufacturer wants to register the drug, what they do is they combine their private business intelligence information with the related witness strings on the blockchain to create a cryptographic proof, essentially saying to the network, I've followed all the business rules, I've registered the drug, or I currently have custody of the drug and I want to transfer it. And this is really how that flow is engaged. So now I've prepared for you an interactive demonstration of this kind of flow. So you see here in this web browser that on the right, I have maintained essentially the state of the blockchain, which will be across all of the different participants. The top will store the random artifacts, the witness strings that I mentioned earlier, and the bottom will show the transactions of each individual participant. On the left, I've already set up 3 individual participants. I've set up the smart contract, and the left it essentially shows each participant's private data, siloed in their own individual companies behind their company firewalls, so no one else can see it. Right now, for us, this is presenting essentially a God's eye level overview of the entire network. OK, so these 3 participants you see present. We have Pfizer, who will function as the manufacturer, McKesson, who will function as the distributor, and CVS, which will function as the dispenser. Each of them have been assigned a unique ID in the network. And so now Pfizer wants to declare to the network, I am registering a drug. So let's say they decide to register aspirin. We give this the unit ID, the serial number that I was mentioning before, and we add. So this is, again, in the private data store. And then we declare the register event. So you can see below in the status says generating proof. So what's happening? Right now, the manufacturer is combining the information about the drug with the public information on the blockchain and creating a cryptographic proof. And now we see it here present on the right-hand side. So on the right-hand side, you can see it's basically a hash. It's the witness string that we mentioned before. And below, we see the public transaction. However, in the inputs, it doesn't reveal any information about the drug at all. We see here is the witness string that was stored as a random artifact in the transaction. And in the final piece is the cryptographic proof, which, when presented to the smart contract was able to verify that, yes, this manufacturer has registered as a manufacturer and is able to create the drug. Next step, we'll try a transfer. So now Pfizer wants to transfer it to McKesson. So what's happening? Essentially, Pfizer is creating a cryptographic proof that's saying they want to initiate a transfer. And they send that proof directly to McKesson. McKesson then takes that proof and the existing witness information and creates another proof that says transfer acceptance. So it's important to highlight that unlike Bitcoin, where the payment just kind of happens in one-party acceptance, in this drug supply chain, we require 2-party acceptance, right? So it takes both of those proofs. McKesson then takes both of those proofs, transfer initiated from Pfizer and transfer accepted that they have, and basically submits it in a new transaction to the blockchain. And we see here, it is this second transaction right below it. And you can see here, it's referencing the witness string of the registration. It's creating a new witness string for the new event. And finally, we have the 2 cryptographic proofs that I mentioned earlier. And so we can repeat this once again to CVS. And the same event essentially occurs. Again, the cryptographic proofs are generated. They submit a final transaction. We see another random artifact in the blockchain state. Finally, we can transfer it back to McKesson. In this case, we're highlighting the action of returns in the pharmaceutical supply chain. And we see, again, one final random artifact. And I mainly show that to highlight to you that there's no evidence, there's no repetition of data here. There's no evidence that a return happened between the same parties. It's brand new information. So there's no way for someone looking at this to correlate that this transaction happened between these 2 parties. So that's the solution that we've come up with for the pharmaceutical supply chain. But it's important to highlight that it's really easy to generalize this solution to other supply chain ecosystems. All it requires is a rewiring of the smart custody contracts and a formalization of the protocols. So it's really widely applicable. So that was the main demonstration that I wanted to show you today. Thank you so much for your time. If you have any questions about what we're doing, we're also working on a lot of other technology solutions. So I highly encourage you to come visit our booth, and we can talk to you directly about this or any of the work we're doing. Thanks so much.
Hello, everybody. Good afternoon, ladies and gentlemen. My name is Stephen Becker, and I am head of risk at MakerDAO. In brief, MakerDAO is a decentralized organization that looks to facilitate economic growth on the blockchain through the use of its stablecoin. And today what I'd like to do is present to you an application of that. What I look to cover today is trying to figure out what a supply chain is and what the supply chain is in relation to a blockchain. Then go into examples about what debt factoring finance is and supply chain financing as well. We'll have a look at where Maker fits into the framework of supply chain financing, and eventually we'll end off with the collaborations that we have in the space at the moment. So the starting point will be obviously looking at the supply chain and the blockchain with the very obvious question, what is a supply chain? Well, conceptually, it's quite simple. It is literally the product life cycle from the purchase of raw materials all the way through to the final product. Functionally speaking, well, that is a management of time and inventory levels and, as well, the collaboration of participants in this life cycle. But from an industry point of view, and this is quite interesting, it is the operational infrastructure as well as the regulatory environment that facilitates this $50 trillion transaction value in the global economy. But it's certainly not without its challenges. And those challenges can quite easily be seen in 4 points. The first is siloed data. Now, this is not data that is private. This is data that should be accessible to all participants in the supply chain. The second one is traceability, looking at the transactions that came before your product all the way through to the end and final form. The inefficiency, which is really quite interesting, at any one moment, there is about $4 trillion worth of working capital locked up in the supply chain. And then finally, authenticity, proof of provenance. Where did this thing come from? Now, this can be encapsulated in a very simple question. How do you know the food that you're eating is organic? How do you know the product that you've purchased isn't a counterfeit? Well, the blockchain goes some way to actually remedying these challenges. The first being siloed data is pretty obvious. We're on a distributed framework, so that is covered. The second, traceability, that is remedied through immutable transactions. Authentication, you can create a digital passport for your asset. You can actually see where it came from and where it's going to. And then from an efficiency point of view, permissioned stakeholder access. That allows you to see the information that you need and act appropriately. Now, at this point, we've seen what a supply chain is. We've seen the use of a supply chain in general and the possibility of its improvements on the blockchain. But what about the actual underlying financing? What are we talking about here? Well, to present this to you, I thought maybe a very simple example would work. I mean, we just came out after lunch. I think a lot of us might be a bit dozy. Reading too many slides might actually add to that. So there's a lot of pictures, I promise. The first thing that I'd like you to imagine is that we're a small company. And as a small company, what we're planning to do is we went and took our 3 clients out for lunch and we secured some great contracts. And on those contracts, we said, great, we're going to supply you with some goods, and with those goods, we're going to send you some invoices. All very good. Please note that the clients that we have, large co, medium co, and another small co, what I'm trying to imply there is that 2 of our customers are much bigger than us and most probably have a better credit quality than us. But we supply them with the goods and we give them the invoices. What do we do next? We place the names on our accounts receivable, which is that little document on the side. Whoops, let's go back. This one. Nope, that's not going back, that's going forward. Is this going to kill me? I think it is. Oh, there we go. There we go. So we could start from there. So that little document over there is our accounts receivable. Now keep in mind, this is an asset for the company. It has value. And so what we'll do is we'll go to the bank. And this is quite interesting. A bank is called a factor. And that's where the phrase debt factoring comes from. And why it's called a factor is actually for some strange reason. It's in order to show on the balance sheet that this isn't a loan, that this isn't debt. So that's why they call it factoring. But as proprietors of this nice little company of ours, we go to the bank and say, listen, we've got this wonderful asset. Can we get some finance on it, please? Ideally, the bank should say, certainly not a problem. We'll take a bit of a fee, but there's your funds. And once we get paid by our customers, we'll bring you back the money, and you make a 3% profit. But what happens in reality is a little bit different. In reality, You go to the bank, and the bank says to you, well, I think that your credit is a little bit too much for us to handle. So as a consequence, we're going to hit you up with a larger cost. And that cost is going to be prohibitive. It's going to affect your profitability. So you're obviously going to be very angry. We turn around to the bank and say, that's rubbish. What are you going to do about this? And then the bank says, well, if you don't like that, the other option is no financing at all. And from that perspective, being a small company, you think, well, what are my alternatives? And this is where we have a look at supply chain finance. So let's start again from the beginning. We have our customers, large co, medium co, and another small co. We send them their goods, and we supply them with their invoices. But the next step is we ask them very nicely to approve those invoices. What does that actually mean? That means they stamp the invoice, and they say, this is a legitimate invoice. We owe money on this invoice. And we then take those invoices straight to the bank. Now, why is the bank a lot more happy about this? Well, these are better credit names. These guys have better credit quality. So now the financing can be a lot cheaper. And for us, that hits the bottom line, and it makes a lot more sense. Another thing that comes from supply chain finance is that if you can reduce your exposure from transferring the credit quality from yourself to your customers, you can actually open yourself to further debt factoring finance with guys that are on your customer list but the same size as you. And because your exposure is lower, you might actually get a better rate from the bank as well. Now, what happens at the end? It's pretty simple. The bank gets 2 streams of payment. They're delighted by that. It's a diversified payment stream. It makes them feel a lot more secure in terms of actually providing that finance. Where does MakerDAO actually now fit into this? Where does this decentralized solution now work into the supply chain finance? Well, if we take a brief moment to look at what it is that we're actually doing at MakerDAO, the provisioning of a stable coin. I'm going to keep it very simple. I'm not going to go into any technicalities. I'm just going to have a look at the process that we use. On the left-hand side, an organization or an individual pledges their collateral, an ERC20 or 721 token. That collateral gets pledged to the MakerDAO system. As a consequence, the system opens up a credit facility. That credit facility is in DAI. You can draw DAI from that and then use it to transact with on the blockchain. That's it. That's as simple as the process is. So there's 3 things you need to remember here. The third one I'll tell you. The first is the pledge of collateral. The second one is the credit facility, the opening of the credit facility. And the third and most important is the fact that, once again, okay, I'll just say it quickly. Once again, the DAI is pegged to the dollar. So the store value is maintained within your transaction. Now, obviously, if you want to close your credit facility, because you can't have it open forever, you go back to the blockchain, you purchase your DAI, you send it back with a stability fee, very much like an interest rate, and the facility gets closed down and your collateral gets returned. Now, with that sort of brief interlude, let's go back to the supply chain picture. I'm going to simplify this down to one customer, being large co, approving the invoice, and at the same time, looking at only one invoice. So this is the direct example of how MakerDAO can be included in this space. So we got an approved invoice from large co. He sends it to us. He doesn't send it to a bank. He sends it to us. And we, in turn, send it to a supply chain organization on the blockchain, who in turn creates a token that is backed by that particular invoice. It's usually, and should be, a non-fungible token because it does represent one particular invoice. That token then gets pledged to MakerDAO, a facility gets opened up, and you know the rest. But in this particular scenario, you can turn your DAI that you receive from your supply chain organization into fiat so that you can use for your own working capital and transactional purposes. Then, when payment time comes around, you find that large co will pay your funds in fiat. You translate that fiat into DAI, pay down your facility, as we showed in the previous example. You get your collateral back, your ERC71 token. But this time, it gets burnt. Why is that? Well, it represents an invoice, and that invoice has been satisfied, so it's no longer applicable. The second option that we have, and this one looks a little bit more confusing, but it really isn't, is if we as small co, we decide, hang on, why don't we take all our invoices? Why don't we take them all and go to a supply chain organization on the blockchain and say, well, instead of looking at one at a time, how about you take them all? Because there's a simple concept of diversification of risk if you assume all these invoices. The organization says, sure, not a problem, converts them into the requisite tokens, and then sends them to an asset bundler. And then they, in turn, create a token backed on those invoices again that gets placed within the MakerDAO system. And as per usual, we get the DAI out, gets converted into cash, and small co, we can use that cash for our working capital and normal transactional purposes. When we pay it back, the same concept happens again. Fiat goes to purchase DAI with a stability fee. That gets paid back to the MakerDAO system. You get a release of collateral, but this time, the collateral goes to the asset bundler, who then releases the underlying tokens that made up that particular token. Depending on the structure, those invoices could then get burnt as well. So, with that in mind, we've spoken about how the supply chain financing works, how it can actually work on the blockchain with MakerDAO. Now we need to look at who these guys are that actually are on the blockchain as supply chain finance organizations. We've got two to share with you today. The first one is a very obvious and very prominent one. We just secured a collaboration with them not so long ago, Shyft. Now, the interesting thing about Shyft is they're very well established. They just raised a $250 million round in conjunction with Goldman Sachs. But what I'd like to do is point out the third point over here, that they look after 1.5 million companies across 190 countries, and they represent $500 billion worth of transactional value. And the last point is that Shyft has created Shyft Cash in conjunction with MakerDAO to create a more frictionless on-demand liquidity within that supply chain finance space. And we're really excited about that. And the one aspect that it didn't bring to the fore is we need to consider the space in general. Now, the second bunch of folks that I'd like to talk about is Centrifuge. Now, these guys are the up and coming. They're very interesting. They have a decentralized system, and they do have many years of experience within the supply chain space, specifically with Trolia, but it is their decentralized representation of all documents that's very appealing to us because we can possibly match our platforms together. And as such, we're exploring all kinds of avenues on how we can actually do that. So at this juncture, what have we done? We've seen supply chain. We've seen how supply chain relates to the blockchain. We've understood what supply chain finance is and how supply chain finance could be a lot more efficient using MakerDAO on the blockchain. But more importantly, we've also identified who our collaborators are. And that is basically it. Thank you very much. If there are any questions, I will take them at the booth around the corner there. Thanks again.
Hello, San Francisco. My name is Bruce Solkoff. I'm the CEO of Shyft. I've been traveling the world spreading the gospel about what we're doing. So I just came back from Singapore, from Hong Kong, from London, from Manila, but love San Francisco. And as much as I love San Francisco, I'm even more passionate about blockchain and how this is going to change the world. So I got 10 minutes to tell you about Shyft, and hopefully you'll be as passionate as I am. They say that necessity is the mother of invention. We have a huge need in this world for what Shyft is doing. I'm going to share some numbers with you, and you'll know what I'm talking about. Every day, 7.2 million records are compromised. Every hour, 300,000 data records are compromised. By the time I get off this stage, 75,000 new data records will be compromised. That's why there's a need. We got a big problem, ladies and gentlemen. Of those records, 70% of them have to do with your identity. So when you get up in the morning, think about it. Think about how many people know everything about you. That is alarming. In 1984, and I'm old enough to know this, in 1984, Andy Warhol came out with a public service announcement that said, it's 10 p.m., parents, do you know where your children are? Let's move that forward to 2018 and rephrase that question to, ladies and gentlemen, it's 2018, do you know where your personal data is? Here's the problem. It's actually more than a problem, it's an epidemic. Today we are repeating where we are giving our personal data. Every time you apply for a product or a service, people ask for your data, they are collecting it. Think about how many times you're doing that. Then people are taking your data and centralizing it, putting it in one location. When you do that, that makes for a very ripe target for thieves to go after it. Governments, regulations are also very compliant, so the burden put on us to actually comply, to protect against money laundering, to do KYC, AML, is a huge burden that companies don't want to be doing, but it's a cost of doing business. JP Morgan, about a year and a half ago, had to hire 13,000 additional employees just to KYC and AML their customers. At about a cost of $100 per KYC, that's pretty onerous. Silos are also a problem. In today's world, we are individually keeping the data in our own database. You go to a bank, you could have the insurance department, you could have the mortgage department, you could have wealth management, you could have retail banking, credit cards. They will all have their own silo of data. There is no interoperability across divisions within your own bank. Now spread that out in your own city, in your own country, in the world. How many silos of your data exist? What we need to do is we need to streamline data. We need to have it in fewer locations, but share that data. We need to make compliance more efficient. So if somebody else has already done a KYC on you, they could attest or validate that KYC. You don't have to duplicate that effort again. And then interoperability. We need to be able to talk to systems across institutions and across geographic borders. Shyft is the remedy to this epidemic. What are we doing? We're leveraging proprietary blockchain technology to essentially build a network, a distributed network, to allow for the secure sharing of trusted and compliant data. There are three players in our ecosystem. One is the individual, the person like you and me who owns the data, whose personal data it is. The second participant will be what we call a trust anchor. Those are the ones that hold the data, and those are the ones that will validate or attest to your data. The third person would be the client, or that's the individual who actually, or institution that needs that new data. Let's give an example of how it works. Imagine you go into a bank. You want to apply for a new account. My personal data is required by the bank to open up that account. In the Shyft network, instead of me having to fill out the forms and go through the whole KYC AML check, all I have to do is give my consent for them to go to a trust anchor in our network to validate my personal data. The client or the bank that I walked into will ping our network, get that data, securely encrypted data, and pay a fraction of the cost to get that data from someone who already has that data. What's the benefit to the client or to the bank I just walked into? One, it reduces the cost and the effort required to KYC that person. Instead of paying approximately $100 to KYC or AML a person and have the employee actually do that, I could do that for, let's say, under $10 to get that same data. I don't have to hold that personal data anymore because that data I'm accessing from somebody else's database. And I could make a decision a lot faster. So imagine walking into a bank You know, banks pay about $200 to $300 in an acquisition cost to get a customer. Imagine going into a bank, sitting there, and they say, oh, we can't make a decision on you today. You'll have to come back. Well, that gives me an opportunity to change my mind. It gives me an opportunity to go to a competitive bank. Now, they can get that information while I'm sitting in the chair across from them. So it makes it a lot better for a bank to actually close that deal. It makes it more efficient for the consumer to get an answer right away while they're sitting there. From the trust anchor's perspective, the one that actually holds the data and the one that is going to be validating the data in our network, it's an opportunity for them to now monetize the data that they hold. So they have spent $100 to KYC you. Now somebody else is pinging the network. They can sell it to them. So you sell it. Let's say you get $5. Let's say you get $2. It's all market forces that determine what you're going to get. But you keep doing that a few times, you're recouping some of the money that you put in to initially collect that data. From the individual standpoint, we talked about faster service, faster decisions, but we also have less risk of our data being compromised because it's held in fewer locations. It's also the ability in our network to provide banking services to those that are unbanked or underbanked. I don't know if you guys know the statistics, but there are 3.5 billion people in this world that are either under or unbanked. The United States, which is the richest country in the world, has about 60 million people that are either underbanked or unbanked. So who's in our ecosystem? Currently, we have billions of data points and profiles committed to our network. They range from governments, regulators, NGOs, telcos, software companies, social networks, businesses, hospitality, pretty much anybody that needs or has collected our personal data. What else are we doing in terms of, in addition to just collecting and providing this network of data exchange? We're leveraging biometrics and social physics to actually provide credibility and reputation scoring to individuals. Imagine you want to go into an Airbnb, for example. You want to, someone wants your condo. You want to rent it out to them. You know who they are, the identity, but don't you want to know the risk factor to how credible is that individual? What's the likelihood that they're going to trash your place? We're going to be able to provide not only validation in terms of identities, but we're also going to be able to provide credibility and reputation scoring to it. AI, artificial intelligence, machine learning, we are striping data to add more security on the data, and electronic IDs. We're doing a project called the Bermuda Stack out of Bermuda, where we're taking all the country's residents, moving them from an analog ID to a digital ID with a full consent framework and interoperability, first within the country, and then take it globally. This will be a sandbox for the planet that we're really excited about. We have a premier who's been progressive thinking and who's enabled us to build this blockchain-based sandbox for the world where a lot of other jurisdictions are following. That's why I went to Manila, for example. That's why we're in countries all around the world. The important thing is that we're working with governments, and they are writing legislation to enable this blockchain adoption to happen. It is required for that to take place. And the last thing and most important thing to me from a personal level is the social impact we are having as a company. We are going to enable these 1.1 billion people in the world without legal ID to actually get IDs, to have access to essential social services like healthcare, schooling, the right to vote, the right to own property, et cetera. Identity is not something that you should earn. It is something you're entitled to from birth. So we are fixing that problem, and I'm proud to be part of initiatives with the European Economic Commission, with ID 2020, with the UN and other nice social impact countries. I have a red light, so I gotta be quick. We do have a strong advisor board behind us. We have people from the crypto world. The co-founder of Ethereum is part of our advisory board. We have people from traditional businesses like an SVP at MasterCard, people from British Parliament, Lords are on our advisory committee. So people ask for two things: use case. You see here, it's obvious based on the epidemic we're facing, strong use case. We also have credibility because of the people that are willing to put their reputation behind this company. I hope you enjoyed that, and I hope you're ready for a paradigm shift. For those of you that want more information, a white paper is available on our website. It's Shyft, SHYFT.network. Thank you, San Francisco.
Hey everyone, how are you? Fantastic. So Blockparty, live event ticketing. My name's Shiv Madan. I'm the CEO and co-founder. I think our CTO, Rakesh Thapa, is in the audience somewhere. So the topic for today is mass adoption, and how do we get there? It starts with infrastructure, as we all know, Ethereum, Shyft, all the building blocks. But how do we reach the end consumer in a way that's engaging, that's emotional, that is something that people really want to do and be a part of? And we think it's through live events. You're all here today at a tech conference. Whoops. Can I just go back a slide, please? Music, sports, and museums, art, those sorts of things. It's a way that people interact on weekends in ways that they enjoy. It touches the hearts of everyone. So we think that that's the way to get there, and we think that there's tons of problems. So I used to own a music festival, in my spare time. 20,000 people, Lil Wayne was the headliner, and frankly, it sucked. It was a real travesty in the way that we were selling tickets, in the way that we were accounting for tickets. Scalpers, bots, fake tickets, fraud, and the hardest part of it was how to get people in the room. And a lot of blockchain conferences, tech conferences can attest to the same thing. How do you fill the stadium? So fake tickets, I was recently talking with a friend of mine at T0, and he had bought 4 tickets for $1,000 to an event at Barclays Center. Standing in line, walks in, waiting for hours. He gets to the front, fake tickets. Wasn't allowed in, had to go back to the will call desk, buy more tickets at an even higher price just to get in. So it's real, and I'm sure a lot of you guys have experienced it. Unfair prices. Why was that ticket $250 for a $50 ticket? These are the types of problems that blockchain can solve. Unsecure venues, and I really hate to put this photo up, but I mean, the reality is Ariana Grande, Manchester, know your customer, who's coming in. And empty venues, we undersold. Frankly, and that's why I still don't have a music festival, because we undersold at that festival, and there was a reason that it didn't succeed. It's not just social marketing that doesn't solve the problem. Tokenization, that does. So we think that live events is the ultimate consumer blockchain use case for now, but it's a way to get to everybody, to all of you in the room. And so what we've done so far is we've built primary ticketing, we've built great security, and the ability to sell tickets. So you buy a ticket, you can't make it, you sell it within the protocol. And what ultimately we're going to be doing is creating a mechanism for demand tokenization. And I'll show that to you today. And one of the things I'd like you to see a little bit later on is the app, how it works, and how you can get tokens in the room for everyone who's geofenced here. So what we started with is obviously matching the current market. So the Eventbrites, Ticketmasters, Ticketflyers of the world. Let's make it as good, if not better. Bring in other tools that have come to the modern world that these companies have not yet introduced, the AI, and enable better productivity around events. So creating a protocol not only that has the base blockchain, but has the ability to stand above and beyond in terms of the base functionality of what is currently delivered in the market. The beauty of our system is a couple of things, and we decided to make digital identity super simple. Everyone talks about digital identity as being a significant blockchain use case. You have your phone, facial recognition, or touch ID. We associate that encrypted digital identity, that hash, with your ticket. So now, when you're entering an event, you have a ticket that's associated with digital identity. We know it's still anonymized, but we know who that person is through the fact that they've registered on their phone. And if you're selling it in secondary, there's no resale market with the bots and the brokers coming in, because when you transfer it to someone else, it deattaches your digital identity and attaches it to the new person. So we're in a situation where we still know who that is in secondary markets. And with our smart contracts, I think we've done something quite unique and quite distinct, and I think necessary for the ticketing industry and necessary for other non-fungible assets, games, music. So every digital asset has a different, distinct characteristic. Tickets, general admission, VIP, underage, drinking age, seated. There's so many different characteristics that if you created it in a CryptoKitties kind of manner, it would bog down the Ethereum network. We have to have high-frequency transactions, 100,000 people entering outside lands at the same time. So how do you create that high frequency at the same time as having a non-fungible token? And we did that through combining ERC 721s and ERC 20s in a fungible manner so that it doesn't bog down the Ethereum network, but at the same time delivers digital identity, the digital asset that is required for that specific situation. And that solves a ton of other challenges as well, but I can get into that in a longer discussion. Moving. So with our current app, we have the ability to pay in crypto and the ability to pay in fiat. And the reason that we started with fiat is 99% of people go to events in a normal manner. They're not sitting in this room. They're not blockchain or cryptocurrency enthusiasts. We want to get that mass adoption and provide them with rewards in crypto so that the next time they come, they can pay in crypto, and start generating use or interest in cryptocurrency. And then with tokenized demand, imagine that you're standing at a stage in front of your favorite artist at a music festival, rather than going to another stage with another artist. Why not geofence that area and you can earn a digital reward, a music download or crypto for actually being in the right place at the right time, supporting your artist, creating engagement. Why wouldn't an artist certainly provide that benefit? Have I gone over time? No. So in the last couple of minutes, what I'd like to do is just have you see how the app works. If anyone's, I know that a lot of people are on their phones, hopefully not disinterested, but we have apps on App Store and on Android available now. And what we'd like to demonstrate is that if you buy a ticket to this event, if you register now or within the next hour, you buy a ticket to Blockparty at Distributed, you'll earn 25 box tokens in rewards within the next hour for everyone who's geofenced in here. So we wanted to demonstrate in a fun and unique way the kind of things that we're offering to our own customers at events and individuals over the next year as we develop the protocol. So with that, hopefully you're all on your phones and trying to get those 25 tokens. But thanks so much for your time. And if you have any other questions, I'll be outside in the booth area. Thanks so much, guys. I appreciate it.
Okay, so First things first, how's everyone doing? Nice. So my name is Tawanda Kiembo. I work from Golix, a cryptocurrency exchange. We're just focused on making it super easy for people in Africa to buy or sell cryptocurrencies. Today I want to talk about an idea we care deeply about at Golix, which is the idea that everyone deserves financial autonomy in the context of Africa. So when you think about it, Africa today is the hardest place in the world to do international payments, to do online payments, to collect money internationally. Where I'm from, and I'm from Zimbabwe, even today in 2018, when a small business wants to make international payments, because you can't do it via the banks, those that don't use crypto actually try to get cash on a black market, put it in a duffel bag, and drive across the border to make an international payment in South Africa or Zambia. We think that's ridiculous. It's the problem we're solving. I know we all got into cryptocurrency for different reasons, but for me, it's really because I felt government shouldn't be in charge of money. And I'll tell you a story. One of the reasons I got into cryptocurrencies is because I witnessed firsthand the wealth my family had built over 4 generations basically lose its value in just a few weeks because we couldn't take money out of the bank fast enough when we had hyperinflation in Zimbabwe. So in 2008, 2009, Zimbabwe had the worst hyperinflation the world has ever seen. I was in college at the time. I was studying computer science at the University of Zimbabwe. And I still remember, as if it was yesterday, walking in a bar, realizing I've got enough money to buy 6 beers, so I buy a 6-pack and I carry it to my table. And the reason I bought a 6-pack is because every time I would have gone to the counter to buy another beer, the price would have gone up. And that's how fast prices were going up in 2009 when we had the worst hyperinflation the world has ever seen. So when I first heard about Bitcoin, you didn't really need to convince me that that government shouldn't be in charge of money. To me, it was a no-brainer. But when the government screwed up the economy, so there's a joke we tell in Zimbabwe, I don't need a girlfriend because the government screws me every day. So when the government kind of screwed up the economy by printing money as fast as they could, like Zimbabwe went to being one of the poorest countries in the world. And it's funny when you look at the history of Zimbabwe between 1980 and around 1999 and around 1991 when Zimbabwe was just got its independence. Zimbabwe had the highest per capita surplus in the world. So which means if you take the difference between what we exported and what we imported and what we are left with, we had the highest per capita surplus in the world after 2 countries. So only 2 countries were before us. But when the country couldn't borrow any more money because it got hit by sanctions, and we didn't have a good store of value locally, we had a $100 trillion note after we removed 12 zeros from our currency. It quickly went to being the poorest country in the world, one of the poorest countries in the world, and it kind of demonstrates why financial autonomy is important. So cryptocurrency is kind of changing all that. So I'm sure you know Africa is famous for leapfrogging technologies. We did it with the landline phone. People just moved straight to mobile phones. We now have more mobile phones than people in Africa. We did it with financial services as well. You don't really need a bank account if you're in Africa, so most of us are using mobile money. But another concept we see that's exciting at Golix is how Africa is starting to leapfrog venture capital. So we're starting to see more companies more success stories, so companies raising funds via token sales and ICOs, and kind of leapfrogging venture capital. We've never really had any VCs that were investing in technology startups in Africa. And as I'm wrapping up and getting to the end of my presentation, I want to give you a few ideas to take home, which is that Africa is it's really the next big opportunity. So when you look at the average growth rate in all the African countries is around 7%. So it's one of the highest in the world. Africa is the youngest population in the world. Technology penetration is increasing very fast. Internet penetration doubled in the last 6 years. A third of Africans are now connected to the internet. Android phones are getting cheaper. China has figured out how to make them cheaper and deliver them to Africa. And so, as I wrap up, an idea to think about is we should be investing in Africa, and it's a country we should be looking at. If you'd like to learn more about what we're doing and how you could get involved in bringing cryptocurrencies to more Africans and making it a lot easier to buy or sell cryptocurrency in Africa, would love to connect with you. Golix.com is our website. And thank you.
Hello, everybody. My name is Jessica Angel. I'm here with TrueBit.io, a scalability solution for the Ethereum blockchain. I am TrueBit's artist. How about that? I think this is a very unusual project that I'm going to tell you about. TrueBit created the Doge Ethereum software bridge between Dogecoin and Ethereum. It's a collateralized peg, and they claimed a bounty that was put out there for whoever could complete this bridge. So once they claimed the bounty, TrueBit called me and hired me to create a physical representation, a physical manifestation of this software bridge. So I'm a visual artist. I create these large-scale installation pieces that take over spaces, walls, floors, ceilings, and they represent the space of information. I think about space from the three-dimensionality of space, but I also think about space in the information world, the virtual space, and I try to create comparisons between these two spaces. So I came up with this concept of a public art structure that is representing a public blockchain. So together, using Slack in collaboration with the TrueBit team and community, we came together with making a bridge that people can walk over, made out of steel. It's 22 feet high, 35 feet wide, and 40 feet long. So you can see here different versions, different perspectives of this object. It's going to go to the Vancouver Biennale next year. And it's going to go on the Hinch Park, the Vancouver Biennale of Public Art. Now, this structure is going to be up for a whole year, and there's a whole public programming that we're putting together to fill in this space during a whole year with education programs, with talks, lectures, and with art that has to do with art and blockchain. So the project itself gave birth to a new organization that we're just calling #ArtProject, because it happened to be called #ArtProject on our Slack channel. So just keep it simple. You can take a look at it, artproject.io. And then artproject.io has become this community of artists and programmers and funders and enthusiasts in this convergence, in this intersection between art and blockchain. You can find us on Telegram. We have a kind of a really active space where we're discussing all these ideas about how we can connect art and blockchain. So we're going to different places to ETH Denver, the Ethereal Summit, creating maker spaces and inviting programmers and artists. We're working with Status also, who's offering bounties in these maker spaces for people who could connect the art structure to the blockchain in real time. How can we make this art structure an open source art project that it's out there that we can build together layers on top to make it activated? So there are actually 2 pieces that have been developed already, connecting with Raspberry Pis and Arduinos the data to the structure. So the public art structure is going to have this, what I'm calling it, the Doge Ethereum arcade. So you remember, you go to an arcade, you buy your tokens, and then you just go around and play around with the different things, kind of games. So this is a really fun experiment. The plan is that you go, once you enter to this crazy shape, you mine your tokens. So that's the first one of these pieces that we already developed. It's 2 blocks. It's 2 blocks that you start hitting with a pickaxe, and the more times you hit it, you have to compete with someone. You earn your token, your reward. There's a screen that is going to show you on a ledger who earned the reward, and you're going to see it. So it's kind of this initiative to create a bridge, again, and connect people who don't know about blockchain, who just happen to be walking in the park and enter this space that is intriguing, and mine their token, and have a very first experience with what blockchain is from a sensorial, experiential perspective, more than a cerebral one. So that's the goal, to educate in a very ludic and fun way. So the mining blocks are going to allow you to mine your tokens. Once you have your tokens, this is an example. So you start hitting the block. Once you're hitting it, the lights are going to start changing into this progressive flow until you earn your reward, your token. So we actually have an open call. It's open right now until about December. So if you have ideas on how to represent this, how to play around, please feel free to reach out to me. We're considering things. We're partnering with people from different fields, so if you like these ideas, that's great. So these are some of the examples that we have developed. This is an artist called Benton C. Bainbridge, and he has this piece called the Lisa Joy. So you would be able to play with the Lisa Joy. It's a projection that's using all these old machines from 1977 video games that are being distorted and playing around. It's just really fun. We have the gumball machine. You can actually go buy gum with the tokens that you mined inside the structure. Data visualizations. With the status bounty, we created another piece using the Whisper mailbox, which is a status app for messaging for, it runs on the Whisper network. And you can actually send a text message, and once you do, it's going to light up a stream of LED lights. This is another collaboration. We invited another artist who created these sort of places where people would sit and get their portraits projected on these sort of reticle of pixels. So there's so much we can do. So I invite you guys to join our Telegram, talk to us, take a look at the project, and really open the dialogue on how, with your projects, whatever they are, it doesn't really matter. You do have a space to play around and use your know-how, your technology, in a creative way. Who knows? Art is something that there's no pressure here. You don't need to do something that is going to be entirely functional, but creative. So this is pretty much an invitation for everybody out there who feels creative. There's a space for that. So thank you so much, and I hope to hear from you if you have ideas.